The flip video about mole ratios, which is the beginning of stoichiometry. So stoichiometry is just a fancy word that has to do with some calculations we're going to do using balanced equations. So let's look at a balanced equation. As we learned in our last chapter, this is the decomposition of water. We have two waters will decompose to two hydrogens and one oxygen. Remember, even though it appears there's nothing here, really there's an invisible one. I'm going to go ahead and just kind of write that one in for our sake. You can write it in or you can leave it out. Normally it's left out. Okay. And so in our problems we're going to be learning about in this chapter, we're going to be creating something called mole ratios. And what mole ratios have to do with are the big coefficients in the front. Okay. In our last chapter we used them to balance our equation, which is correct. So we could say that we had two molecules of water. We can also now use these big coefficients to say that we have 2 moles of water, 2 moles of hydrogen, and 1 mole of oxygen. That's important to write down in your notes. 2 moles. These coefficients can also be representative of how many moles we have. Remember, moles is a number we use in science to count things. Okay. Now that we know that, let's talk about what mole ratios are. So if you think about math class, ratios when you compare two numbers against each other. So if I was to say, what is your ratio of moles, you would compare these numbers in the front. So if I was to say, what's your mole ratio of water to oxygen, you would say it's 2 moles of water for every 1 mole of oxygen. Now, if we want to bring a little bit more chemistry in it, remember, this is the reactant and these are the products. So if we look at that, we could say 2 moles of water react to produce 1 mole of oxygen. Okay, so let's write that down. 2 moles of water, right, react to produce 1 mole of oxygen. Now, another way of saying that for us is in this way, right? Is 2 moles of water per every 1 mole of oxygen. I got these numbers from the coefficients. Okay, good. I got these numbers from the coefficients. That's called a mole ratio, and that's the way we're going to be using it. You can also flip it. You can also flip it to look like this. 1 mole of oxygen per 2 moles of water. Where did I get the 1 from? It was in front. I get my moles from the coefficients in the front. For 2 moles of water. What's the coefficient in front of water? 2. That's where I got it from. Now, hopefully this is looking familiar. And the reason why we use it like this is, guess what? This is going to be a conversion factor for us later today in this video. Okay, now, we could even make a relationship between the hydrogen. I didn't leave that out. So if we look at it right now, we've got 2 moles of water for every 2 moles of hydrogen that get made. Remember, for mole ratios, we're only looking at the front numbers, not these little subscripts, just the front. And if you notice, I didn't reduce my mole ratio. Don't reduce your mole ratio. Keep it just like you see it because they're representative of the coefficients in the front. Notice I didn't reduce it here because it's already down to its lowest possible numbers. Okay, so our first problem is going to look like this. Here are our new problems. How many moles of O2 will be produced from 6.2 moles of water? Okay, so what this means is, if we're starting off with 6.2 moles of water, how many moles of oxygen will I make? So this water will make how many oxygen? Now, I'm going to talk about these problems in 2 ways. I'm going to talk about these problems in a more simplistic way, kind of like a recipe. Water makes these things. Okay? And then I'm going to talk about how to use dimensional analysis. And the reason why I do this is because sometimes dimensional analysis is very easy to set up, but do you understand why you set it up that way? Does it make sense to you? Maybe not. So if I treat this equation more like a recipe, at first it might make sense to you. Okay? So let's pretend like we're making something. kind of like we're making a cake. These are the things I start off with, and then I make the cake. Okay? So in other words, water makes these things. Think of it like a recipe. If I put in 2 water molecules, I make 2 hydrogens and 1 oxygen. Okay? All right, well, with that being said then, this problem says, well, you're not going to start off with 2 moles of water. Instead, you're starting off with 6.2 moles of water. 6.2 moles of water. So, but if this is what the recipe calls for, how can I fix this to reflect my new problem? Well, let me ask you, if I want to make 6.2, 2 times what will get me 6.2? Okay, let's take our calculators out and figure that out. 2 times what will make me 6.2? So what's an easy way to do this? Well, if I take 6.2 and divide it by 2, right, I get 3.1. So 6 times 3.1. Go ahead and try that in your calculator. Did you get 6.2? Yep, that should be right? So if I have 3.1 of these, then I can actually do this problem. So 3.1 gets multiplied by there. 3.1 gets also multiplied by here and by here. Okay? So in a sense, then, starting off with 6.2 of the waters will give me 3.1 of the oxygens, right? Because if I normally started with 2, then 2 times 3.1 gives me what I really want to start off with, which is 6.2 moles of water. Okay? Now, this is just my formula way of saying it, my recipe way. This is not how we're going to really do it in class. What we're going to do is set up dimensional analysis. So let's take a look at how we would do that. So first of all, you want to start by writing down your given. So let's write our given down. And that is 6.2 moles of water. 6.2 moles of water. Then I want to multiply it by some sort of relationship. So let's bring back my balanced equation. Okay. Now, remember, we said that you can use these to make mole ratios. All right? And if you remember, my mole ratios look like this. I could either say I have 2 moles of water for every 1 mole of oxygen, or I can flip it and say I have 1 mole of oxygen for 2 moles of water. That's my relationship. So which one do I use? Well, according to dimensional analysis, whatever unit's on the top needs to be on the bottom. So this is not right, but this is correct. Okay? So where did I get these numbers from? It might be helpful if you do this and point. They were the coefficients in the front. They help make my mole ratio. So every 1 mole of oxygen gets made when you put in 2 moles of water. So let's go ahead and calculate this in our calculator. So go ahead and take your calculator out. And we're going to do 6.2 times 1 divided by 2. And hopefully when you get an answer, it yields correct sig figs 3.1. We're always going to look at the front for sig figs. 2 sig figs there, 2 sig figs there. We don't look at our mole ratio. And my final answer should be moles of O2, because my moles of water cancel out. And if you remember, that's exactly what my final answer was a second ago when I was showing you the recipe. So 2 moles of water for every 1 mole of oxygen, but I'm not starting off with 2, I'm starting off with 6.2. So always start with your given in the problem and make your mole ratio. Okay, let's try another one. Let's look at this problem. Take a second and write that down. And I have, it says, how many moles of water will be required to make 19.2 moles of oxygen? So the first thing I want to start with is my balanced equation to get my mole ratios. If I don't have my mole ratios, then I can't do this. So this is the exact same balanced equation that I worked with a second ago. Let's put that back up here. Okay. So starting off with a balanced equation is the first thing you need. And if you notice, I'm going from moles of oxygen to moles of water. Okay? So the question becomes then, I want to make 19.2 moles of oxygen, right? I want to make this. So to make 19.2, so if I multiply this by 19.2, my moles, I get 19.2 oxygens. Well, if that's the case, then I have to multiply everything by 19.2 if I want to see how much of the water I needed to begin with. So 19.2 times 2, let's take our calculator out and calculate that. Okay, I get 38.4 moles. So in other words, if I start off with 19.2 moles of oxygen, I'm going to get 38.4 moles of water. Remember, in this example, you're starting with 1 mole of oxygen, and you get 2 waters. You want 19.2. So this is the recipe way. We're not going to do the recipe way. Instead, we're going to do the stoichiometry way. So how do I do this with stoichiometry? Well, the first thing is you want to start with your given in the problem. So I'm going to start off with a 19.2 moles of oxygen. And I want to multiply it by a relationship, a conversion factor. Remember, when you're not sure, whatever's up here goes down here is the best way to begin. Okay? I want to know how many moles of water. Moles of water. That's what I'm trying to find, moles of water. I have moles of O2 and I'm trying to go to moles of water. So I'm going to put moles of water on top. So if you notice, this is my mole ratio. My mole ratio. Sometimes I call it a mole to mole ratio. My mole ratio. And if you remember a second ago, let me bring these back. Here are the mole ratios we created. We got them from our balanced equation, right? We said 2 moles of water for every 1 mole of oxygen. Or we can flip it. 1 mole of oxygen for 2 moles of water. So which one am I going to use here? Well, I want the tops and the bottoms to match. So if you notice, oxygen's on the bottom, moles of oxygen. So I'm going to use this one. Moles of oxygen have to cancel out. Again, where do I get these numbers from? A mole to mole ratio. You get the numbers from the balanced coefficients. So it might help for you to do that arrow thing again and show, right, you've got 1 mole of oxygen, and then this one's all the way from over here, 2 moles of water. So now all I have to do to calculate this is 19.2 times 2 divided by 1. Well, if we take our calculator out and do 19.2 times 2, guess what? We get what I said a second ago. And that's 38.4 moles of water. Don't forget to label. Moles of what? Moles of water. Moles of water. 3 sig figs here in the beginning, 3 sig figs here at the end. You always look at your given when we convert for sig figs. Great. So the big picture here is always start with your given like we always have. Make sure you have your units. Top unit and bottom unit should match. And now we've learned that we could put a mole over a mole, and that's called a mole ratio. So remember, a mole ratio is when we put moles over moles, mole over mole, right? And we get these numbers from our balanced equation. Our balanced equation, the coefficients in the front. And we use them as conversions now. So that's how we are able to go from one substance, oxygen, to another substance, water. Okay? This might be a good video to stop, rewind, and review this. It's a little bit of a tricky one, and see if you can do these again.